Hello, and welcome to another tutorial for the National Institutes of Health High Performance Computing Group, or NIH HPC for short. Today, I'm going to explain how to use Swarm. What is Swarm? Swarm is a script designed to simplify submitting a group of commands to the Biowulf Cluster. Swarm requires a single file as input. So let's create a file using nano, and it'll contain a single command, uptime. I can run that command right on the command line, and it'll show me the load average, how many users on the system, how long the system's been up, some generic statistics. I can submit it to Swarm using simple commands swarm -- file and the name of the file. This submits it to the batch system, and you can see the single job running in the Swarm array. The job ID is suffixed with an _0, which means this is the 0th subjob in this particular swarm. The swarm allocates by default 2 CPUs per command and 1 GB per command. If I type sjobs again, the job is finished. Now, after running Swarm, each command, each subjob in the Swarm results in 2 files, a .o, which is the standard out from the command, and a .e, which is the standard error. If I take a look in the standard out, you can see that's the result from uptime. Now let's say we wanted to run multiple commands. Well, let's edit the file again. Instead of just running uptime once, we're going to run it 4 times. Save the file. And now we resubmit, just like before, swarm file 1.swarm. If we take a look at sjobs, you can see the subjobs are actually pending. If I type sjobs again, now you can see the 4 subjobs running in the swarm array. Again, each is given 2 CPUs and 1 GB of memory per command. If I type sjobs again, they're still running. Should almost be done. Now the jobs are done. Let's say our commands require a bit more than just 2 CPUs and 1 GB of memory. Let's say we have a multi-threaded application and it can use 4 threads or 4 CPUs per command. And it needs a lot of memory, so it needs 8 GB per command. Well, Swarm makes it really, really easy. You say swarm -file and the name of the file, and now you say -g for the number of gigabytes you need per command, and -t for the number of threads, or the number of CPUs per command. Run that. Type sjobs. And now you can see each subjob in the swarm array is allocated 4 CPUs, and in this case 8 GB per command. Alright, let's take a look at some of the other options for Swarm. If you just type swarm --help, a long display of all the different options is listed. Here's --file, here's -g, -t, some other ones. There are some other resources that you might want to allocate with your Swarm. For instance, if you wanted your Swarm to run for more than the default 4 hours, you can say time, and let's say we want to run it for 1 day. Each command will take 1 day to run. That's how you would do it. Let's say you wanted to run on the CCR partition. You'd say -- partition CCR. A lot of commands require environment modules to function correctly. Rather than editing your swarm file, you can just allocate that module within the swarm command line itself. So let's say we say swarm -- file 1.swarm. You'd say module Python R and top hat. All right. If we were to look into the standard error for that swarm, one of the subjobs, you can see the appropriate modules were all loaded prior to running any of the commands. There's one option, there's one flag for swarm that's really, really powerful, and that's -- devel. So if I say swarm -- file 1.swarm -- devel, that runs swarm in a development mode. And it tells you what swarm would do without actually doing it. So in this case, our swarm file has 4 commands, so it would run 4 commands in 4 subjobs, with each job requiring a certain amount of memory and threads, those are the defaults. And it tells you some other information about how much memory in megabytes, the partition, how many CPUs per task, some SBatch specific information. This is particularly powerful, especially if your swarm files have many, many commands in them. So let's say we create a file with 1,000 commands in it. We'll create a file. If we look at that file, we'll pretend that these are the commands. So it has 1,000 commands in it. If I said swarm -- file 2.swarm -- devel, then it shows me that I have 1,000 commands to run in 1,000 subjobs. Now swarm is configured to run no more than 1,000 subjobs for any particular swarm. If I were to create a file with, say, 10,000 commands in it, and I ran the same thing again, swarm -- file, now this time with devel, you can see 10,000 commands were run, but in this case, only in 1,000 subjobs. That means each subjob is actually running 10 commands, and it runs them serially, as you can see. It says running 10 processes serially per subjob. What's happening here is called bundling. Now, to bundle a swarm job, that means to run commands in more than 1 command serially per subjob. This is an efficient way of running many, many commands in a single swarm array without overwhelming the batch system. As you can see, running very large swarms of commands is not a problem at all. But once they get beyond a certain size, then time becomes a problem. Let me demonstrate this. If I create a swarm file of 1,000,000 commands, and I submit it the same way as before, but this time with devel, because they don't really want to run this 1,000,000 command swarm, we get an error message. It says it's exceeded the partition wall time limit. The Biowulf cluster is configured so that no single swarm or single job can exceed 10 hours or 10 days of wall time. So in order to run a single swarm of 1,000,000 commands, each of those commands would have to be pretty fast. So let's say we told it each command requires, let's say, 1 minute. So we have 1,000,000 commands. Each of them is going to run for no more than a minute. How long will that take? Well, we're going to run 1,000,000 commands in 1,000 subjobs. That means 1,000 commands, one after another, each command taking a minute. The whole thing should be finished in 16 hours and 40 minutes. Now, what's happening here is what's called auto-bundling. That is, when you have a large number of commands, Swarm will automatically pile them up into serial lists of commands on each subjob so that it'll fit within the 1,000 subjob limit. Now, you can just let Swarm do whatever it wants, but you could actually manually override this. So let's go back to the command. Let's go back to the 10,000 command swarm job that we were going to do. If we say swarm -- file 3.swarm -- devel, let's say the time limit for each is 2 minutes. It'll pack 10 processes serially per subjob, giving each subjob 20 minutes, that is 10 times 2 minutes. But let's say I don't want 10 processes per subjob. Let's say I want 50. I can say -b 50 to bundle 50 commands per subjob. And let's say each command, instead of taking 2 minutes, takes 10 minutes. Now you can see it's running 50 processes serially. It's going to take 8 hours and 20 minutes to complete the entire swarm. And in this case, rather than creating 1,000 subjobs, you're only creating 200 subjobs. When you're only running 200 subjobs at a time, it makes your impact on the cluster lower. You don't use as many nodes, as many CPUs, and so then you can run other jobs and other users can run their jobs at the same time. One of the downsides of running huge swarms of commands are the huge numbers of log files and output files that result. And so Swarm has an option, --logdir, that redirects the .o and .e files into a directory of your choice. So to demonstrate this, I have a Swarm file that runs our old friend uptime, runs it 10 times. If I submit a swarm, this time giving the logdir to uptime output, all right. Let's see if it's done. Nope, should be done. So if we do an ls of uptime output, there they are. So now if you wanted to concatenate all of that output into a single file, you could type something like this. You concatenate all the .o's into a single uptime output .o, and all the error files into a single .e file, and then remove the original directory. Well, this will conclude the basic introduction to Swarm. If you have more questions, I guess you can go to our Swarm webpage here. It has a fairly large amount of information about how to run Swarm and how it works. And look forward to future videos about advanced uses of Swarm.